In this class, we are going to go over questions on Anova table, Randomized Complete Block Design. You're going to be learning how to compute an Anova table, okay? We are asked to compute an Anova table for this data, and we are given that the F tabulated at 5% for block is 4.46, and the F tabulated at 5% for variety is 3.84. Please, I want you to pay attention. I'm going to take it step by step, okay? So kindly pay attention. Now, we call this experimental design randomized complete block design because we have block. You understand? We have block, and this is the first block, this is the second block, and this is the third block. And we also have variety. These variety are also known as treatments. You understand? So in some cases or in questions, you might not find it as variety, but because of the structure of the question, they name it variety. Variety is for all this crop. You understand? So you might find this as treatment. You understand? So just know that whether variety or treatment, you are still going to use the same step. Okay. Now, how do we compute an Anova table for this data? We have to calculate some parameters before we can compute an Anova table for this data, and that's what I'm going to be doing now. Okay. The first thing to do is that you have to take the row total and the column total. You understand? Just pay attention. You're going to understand what I mean. This is the row, right? And this is the column. You understand? This is the row and this is the column. Now, if you look at, please pay attention. If you look at this data, this is the variety. Let me write it here. Variety. We are having how many variety? We are having variety 1, variety 2, variety 3, variety 4, and variety 5. You understand? And we are having how many blocks? We are having block 1, block 2, and block 3. Do you understand? Now, let us take the row total and the column total. Here, I'm going to have the column total, and this will be the what? The row total. Now, in this question, the parameter that falls in the column is the variety. You understand? Please, you just have to understand. In our previous class, the kind of randomized block design that we saw, the variety falls in the row. You understand? But in this question, the variety falls in the column. You understand? It is the block that is in the row now. Are you paying attention? Now, you just have to listen, okay? Don't get confused. So the reason why I want to take the row total and the column total is because I need to calculate the correction factor. You understand? Just pay attention now. So I'm going to have another row in this place. I just want to shorten this so that it won't take another space. The meaning of this is row total. You understand? So I'm going to have another bracket here. Okay. Now for the second, for the variety side, I'm still going to have something like this as well. So let's take the sum of the first row. The first row is for block. You understand? In this question, the first row is for block. This is block 1. The sum is what? 3.0 plus 4.3 plus 5.2 plus 5.5 plus 4.0. That will be 22. You understand? So the value of these cells is 22. So here I'm going to have 22. Now let's move to the second row, which is for block 2. I'm going to have 2.8 plus 3.7 plus 5.0 plus 5.8 plus 4.2. That will be 21.5. So here I'm going to have 21.5. Do you understand? Okay, let's move for block 3. That is the third row. I have 2.9 plus 3.9 plus 5.5 plus 5.7 plus 4.5. That will be 22.1. 22.1. Okay, now let's talk about the treatment now, which is the variety. You understand? We are going to have the sum of the variety now. The sum of variety 1 will be 3.0 plus 2.8 plus 2.9. That will be 8.7. Okay? 8 points. Let me check very well. 3.0 plus 2.8 plus 2.9. That is 8.7. So here I'm going to have 8.7. Then for the second treatment, which is V2, variety 2, I'm going to have 4.3 plus 3.7 plus 3.9. That will be 11.9. Okay. Now for the third treatment, which is variety 3, 5.2 plus 5.0 plus 5.1, that is 15.3. 15.3. This is 15, okay? Don't get confused. 15.3, okay? Now, for the fourth treatment, which is related 4, 5.5 plus 5.8 plus 5.7, that is what? 17. So here I'm going to have 17. Then for the fifth treatment, that is 12.7. Their sum is 12.7. Please, do you understand what I'm doing? I take the row total, then I take the column total. You understand? Okay? Now, the next step now is to check maybe the row total is equal to the column total. Hello? If by the time you sum this, and this together, okay, let's do it now. Take the sum of 22, 21.5 and 22.1. What's the answer? That should give you 65.6. 65.6. So here, the sum of the row total is what? 65.6. Okay? Now, take the sum of this as well. Take the sum of 8.7, 11.9, 15.3, and 17, and 12.7. What's the answer? If you didn't get 65.6, that means that something is wrong with your calculation. You have to check, okay? But the sum will be 65.6 as well. So the value here will be 65.6. Do you understand? Okay? Now, having taken the row total and the column total, you can proceed to calculate the correction factor. Okay? The correction factor is given by this formula. Correction factor is equals to summation x all over n. Summation x squared all over n. This is the correction factor. You understand? That is the sum of all the treatments. You understand? Okay, the sum of all the samples that we have in our treatments, sum all of them together, then divided by the total numbers of all of them. You understand? How many treatments do we have? We have 5 treatments, but the samples are what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We are having 15, you understand? So the number n is what? 15 here. So I'm going to have correction factor CF equals to summation x squared. The sum of all the treatment is what? 65.6. So I'm going to have 65.6 all over n. N here is what? 15. So I'm going to have 65.6 all over 15. Okay? Don't forget the square. Let me use, I want to change the marker here. Let's use blue marker, okay? Now, 65.6 squared is what? 4,303.6. So, 4,303.36 all over 15. Hence, the correction factor is equals to 286.89. 286.89, okay? So, let us pen it down. The first parameter that we calculated is the correction factor, which is what? 286.89, okay? Now, having determined the correction factor, the next parameters that we need to calculate is the total sum of squared. Hello? The next parameters that we need to calculate is the total sum of squared. All these parameters are important when in computing our Anova table, you understand? So that is why we cannot just compute our Anova table without knowing these parameters. It is very impossible. It will be impossible for us to compute our Anova table. So that is why we have to go through this step first. Do you understand? Okay, now let's calculate the total sum of squared. All you have to do is to pay attention. I'm going to simplify it such that you won't be confused. Now, the total sum of squared, I'm going to represent it as TSS. TSS. Now, in some question, they might not put it as total sum of squared. You might find it as sum of squared total, SST. It is also the same thing, you understand? You are still going to use the same approach, the same step to calculate it, you understand? So, the total sum of squared is equals to the square of the sum of all our data minus the correction factor. Do you understand? That is, we are going to square all the samples, everything that we have here. We're going to square it. After squaring it, we're going to sum it together. Then the answer, we're going to subtract the correction factor from it. That will be the total sum of squared. Do you understand? The sum of squared of sample minus the correction factor. This is what I mean. You understand? So this the square of the sample will be what? Let's start. We are going to take it one by one and square it. 3.0 squared plus 4.3 squared plus 5.2 squared plus 5.5 squared plus 4.0 squared plus 2.8 squared plus 3.7 squared plus 5.0 squared. Are you paying attention? Plus 5.8 squared plus 4.2 squared. Hello, are you getting it? Plus 2.9 squared plus 3.9 squared plus 5.1 squared plus 5.7 squared plus 4.5 squared minus the correction factor. The correction factor is what? 286.89 minus 286.89. Do you understand? You can see that we have a long way to go. So now I want to square all those values. Let's start with the 3.0. Okay, 3.0 squared is what? 9. 9 plus 4.3 squared. What's the answer? That is 18.49. Okay, 18.49. 18.49. Now 5.2 squared is 27.04. 27.04. Okay. 5.5 squared. No. Okay, 5.5 squared. 5.5 squared is 30.25. 30.25. Now 4.0 squared, that is 16. Then for the next one, 2.8 squared. 2.8 squared, that is 7.84. 7.84. Then plus 13.69 plus 25 plus 25 plus, do you know what I'm doing is that I'm squaring all these values, you understand? That's what I'm doing. 3.7 squared will give us 3.69, 13.69 rather. 5.0 squared will give us 25, you understand? Okay, 5.8 squared, that is 33.64. 33.64 plus, okay, 17.64 plus 8.41 plus 15.21 plus 26.01 plus, okay, this is 32.49 plus 32.49 plus 20.25 20.25. You understand? So all this minus 286.89. You understand? This is total sum of squared, TSS. The total sum of squared. Do you understand? If you don't understand, listen to the explanation again, okay? So now let us proceed. What is the sum of all these? All these values, their sum will be all this value, that is 300.96. Let me just put it like that. 300.96 minus 286.89. Okay? The total sum of squared is equals to this. So total sum of squared is equals to 300.96 minus 286.89. That is 14.07. You understand? 14.07. So you've gotten another value here. The total sum of squared, TSS, is equals to 14.07. Okay? So having gotten the total sum of squared, or sum of square total, the next parameters that we have to calculate is the block sum of squared or replicate sum of squared. In some cases, you might find it at replicate sum of squared or block sum of squared, but in this class, I'm going to be using block sum of squared. Do you understand? Okay? So let's determine the block sum of squared. Are you done with this? Okay. I can erase it, right? Are you done with it? Since you are done, okay. Let's go. Okay, I can even erase this. Yes. Yeah. Okay. Now, to determine the block sum of squared, let me use red marker now. The block sum of squared. The block sum of squared is equals to, you know that this is block. Hello, listen. It's simple, okay? This is block, you understand? And block falls towards the row, you understand? We have three blocks, block 1, block 2, block 3. That means block sum of squared is the square of each block, their sum all over the total number of times the block repeat themselves minus the correction factor. You just use this formula, summation bi squared all over n minus the correction factor. You understand? Use this formula to determine the block sum of squared or replicate sum of squared. See, the meaning of this formula is that I'm going to square the sum of each block. The sum of the first block is 22. Sum of the second block is 21.5. Sum of the third one is what? 23 and 22.1. So I'm going to square each block, then sum it together. I'm going to divide it by the numbers of times each block repeat themselves. Then I'm going to subtract the correction factor. That is the meaning of this formula. Do you understand? If you didn't understand, listen to the explanation again. The next parameter that I want to calculate is the block sum of squared. And I gave you this formula, so in an attempt to help you to understand how to calculate the block sum of squared, that is summation bi squared all over n minus the correction factor. Summation bi squared means the sum of the square of each block. I have three blocks. The first block is block 1, block 2, block 3. And the sum of the first block is what? 22. So here I'm going to have BSS equals to 22 squared plus 21.5 squared plus 22.1 squared. Do you understand? All over the numbers of time the block repeat themselves. The numbers of time the block repeat themselves is what? 1, 2, 3, 4, 5. You understand? Or you can do it like this. Since we have 3 blocks, you understand? And we know that the total numbers of cells that we have in this experimental design is 15. So divide the numbers of cells by the block, by the number of blocks that you have. That is 15 divided by 3. That is what? 5. So n here will be what? 5. N will not be 15, no, don't use 15. If you use 15, you are not going to get the correct answer. Okay? So that's why I give you two approaches. You can approach it in 2 ways to get the value of n. N is the numbers of time, the numbers of repetition, the numbers of time the block repeat themselves. This is block 1, first, second. This is all the 3 block 1, 2, 3. First, second, third, fourth, fifth. That's why I have 5. You understand? Okay? And you can do it another way. The numbers of samples that we have is what? 15. The numbers of blocks that we have is what? 3. 15 divided by 3 is what? 5. 5. You get it? Okay? So subtract correction factor. Correction factor is what? 286.89. Do you understand? It's simple, okay? Now let us square. Let's square all these. Let's square all these values in the bracket. So for this, we're going to have block sum of squared is equals to 22 squared is 484. You understand? So I'm going to have 484 plus 21.5 squared is what? 462.25. 462.25 plus 22.1 squared, that is 488.41. 488.41 all over 5 minus the correction factor, which is 286.89. Do you understand? Okay, now let us sum the numerator together. 484 plus 462.5 plus 488.41. What's the answer? That is 434.66. 1000. Okay, let me write it here. 1434.66 divided by 5 minus the correction factor, which is 286.89. okay, so block sum of squared is equals to 1434.66 divided by 5, that is 286.932. 286.932, okay, minus 286.89. okay, so block sum of squared is equals to 286.932 minus 286.89, that is 0.042, 0.04042, you understand? So here I'm going to have block sum of squared is equals to 0.042. Do you understand? Okay, now having gotten the block sum of squared, they have to determine the treatment sum of squared or the variety sum of squared. You can call it treatment sum of squared or the variety sum of squared. I will just compute it at one side in that place. The variety sum of squared will be equals to sum or summation vi squared all over n. Do you I'm very sure you remember all this formula in our previous class. The first Anova table, in our first class in randomized complete block design, we talk about all this formula. So if you missed the class, I will drop the link in the description of this video. Make sure you watch the class so that you have a comprehensive understanding of what we are doing. So minus the correction factor. So the variety sum of squared, don't forget I said variety is also known as treatment, you understand? Okay, so variety sum of squared is equals to summation vi squared all over n minus cf. The meaning of summation vi squared is that sum of individual treatments, sum of individual variety, we are going to square them, then we are going to add it together. We are going to divide it by the numbers of time each variety repeat themselves, and then we are going to subtract the correction factor. Listen, summation vi squared means sum of all the treatments or sum of all the variety. The first variety, the sum of the first variety is what? 8.7. So I'm going to have 8.7 squared plus the second variety is v2. The sum is what? 11.9. So I'm going to have 11.9 squared plus the third variety is what? v3. The sum is what? 15.3. I'm going to have plus 15.3 squared plus the fourth variety is v4. The sum is 17. So I'm going to have plus 17 squared plus the fifth variety is what? v5. Their sum is what? 12.7. So I'm going to have plus 12.7 squared. Okay, these all over numbers of time. Numbers of time, the variety repeat themselves. This is variety 1, 2, 3, and 4. They repeat themselves is 1, 2, 3. Do you understand? So n here will be 3. Please don't mistake n. Don't say that because n is 5 here, it will also be 5 here. No. Okay, and you can also do it in this way. Since you know that the total numbers of samples that we have is what? 15, and we have 5 variety. Just divide 15 by 5. We're going to have what? 3. You understand? So I don't want you to make mistake in the exam. Okay, so yeah, this will be minus cf. Cf is correction factor, that is 286.89. Do you understand? Okay, the variety sum of squared will now be equals to, if you sum the square of all this value, we are going to have 70. Okay, let's take it step by step. 8.7 square is 75.69. 75.69 plus 11.9 square is 141.61. 141.61 plus 15.3 square is 234.09. 234.09 plus then 17 square is 289. 289 plus the last one is 12.7 square. 12.7 square is 161.29. 161.29. You understand? Okay, this all over 3. Are you paying attention? minus 289 point, oh, it is 286, sorry, minus 286.89. You understand? Okay, so here I'm going to have variety sum of squared is equals to, now sum all this together, we're going to have 901.68, 901.68 all over 3 minus 286.89. Please, do you understand it to this point? If you didn't understand, kindly listen to the explanation again, okay? Now, I want to erase, since we are done with block sum of squared, I'm going to erase block sum of squared. You understand? So I'm going to erase this. Let's erase this so that there will be space to calculate the variety sum of squared. Okay? Now, variety sum of squared is what? 901.68 divided by 3 minus, maybe I should write it here. Okay, so let's go. 901.68 divided by 3, that is 300.56. 300.56 minus 286.89. Okay, 300.56 minus 286.89, that is 13.67. 13.67. So the variety sum of squared, or treatment sum of squared, let me call it variety, since we are given variety in the question. If you are given the question as treatment, just call it treatment, you understand? But since we are given in this, we are given in the question, what we are given in the question is variety, so I'm going to call it variety sum of squared, okay? Variety sum of squared is what? 13.67, okay? Now, let's proceed to calculate the last but not the least. That is the error sum of squared. You understand? The error sum of squared. To calculate the error sum of squared, we just have to take the difference between the total sum of squared and the sum of the square of both block and variety. You understand? That difference will give us the error sum of squared. Maybe let me just write it out, okay? Please, are you done with this? Are you done writing this? If you are done, let me erase this so that we can have space to calculate the error sum of squared. Okay? The error sum of squared, please pay attention. The error sum of squared is equals to total sum of squared minus the difference between the total sum of squared and the sum of the variety sum of squared. You understand? So the error sum of squared is equals to total sum of squared is what? 14.07 minus block sum of squared, that is 0.042, 13.67. You understand? Okay? Please, do you understand it to this point? Okay? So the error sum of squared here will be 14.07 minus, if you sum 0.042 and 13.67 together, you are going to have 13.712. You understand? 13.712. So the error sum of squared is equals to 0.358. You understand? So the error sum of squared is 0.358. Error sum of square error is 0.358. So now, with respect to the experimental design that we are given, we are done with the parameters that we need to calculate. So from this point, we can proceed to compute our Anova table. So please, I want to pay attention, okay, because there are also some calculations that are in that Anova table. You understand? So please kindly pay attention. Okay, this is how a typical Anova table look like. This is how the Anova table will look like. You understand? With respect to the parameters that we calculate, there are some Anova table that we are going to have more than all these parameters. Maybe you are going to have like if there are an interaction, you understand, maybe fertilizer, or if you want to learn more on Anova, just check the description of this video. I have questions that I've already solved, you understand. Just watch those videos to have a comprehensive understanding on this particular topic. Okay, now we have the source of variation. df means the degree of freedom, ms means mean squared, fk means f calculated, that is the calculated critical value that we calculate, and the f tab is the given critical value, you understand, at 5%. Don't forget that at 5% we are given that the critical value for the variety is 3.84, and for the block or the replicate it is 4.46. Do you understand? Okay, so let's start by filling this Anova table. We have the source of variation. Since Anova deal with analysis of variance, we can have the total. Hello, source of variation could be total. Here I'm going to have total. Here I'm going to have block or replicate, block or replicate, and here I'm going to have variety or treatment. Please listen to me. It is what you are given in the question that is going to determine what you are going to put down in this Anova table. If you are given treatment, write treatment. If you are given replicate, write replicate. You understand? And if you are not given maybe block, or if you are not given block like this, you can write replicate. You understand? So just I felt it is important to let you know like that. Okay. So and the last column here will be for error. You understand? Okay. Error. Now we have the degree of freedom. How do we get the degree of freedom for total? To get the degree of freedom is given by this formula. Degree of freedom is equals to n minus 1. So now we want to get the total degree of freedom. The total degree of freedom is equals to Tn minus 1. The total numbers of samples that we have minus 1. Total numbers of samples is what? 15. You understand? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15. So here I'm going to have 15 minus 1, which is what? 14. You understand? So for the value of these cells is 14. Okay? Now let's move to block. How many blocks do we have? The block, okay, sorry. Let's continue with black pen. Block degree of freedom is equals to block, total numbers of block minus 1. How many blocks do we have in this experimental design? We are having obviously 3 blocks. You understand? So here I'm going to have 3 minus 1, which is what? 2. So for this I'm going to have 2. You understand? Okay, now let's move to variety. To get the variety degree of freedom, will be equals to variety, total numbers of variety that we have minus 1. And we are having how many variety? We are having 5 variety, which is V1, V2, V3, V4, V5. 5 minus 1 is what? 4. So here I'm going to have 4. You understand? Okay, now how do we get the error degree of freedom? To get the error degree of freedom, you just have to use this formula. Error degree of freedom is equals to total degree of freedom minus, let me change this marker. Total degree of freedom minus the sum of the block degree of freedom and the variety degree of freedom. You are going to use this formula, you understand? Just subtract 14 and 2 plus 4. That's what I mean. So here I'm going to have 14 minus 2 plus 4. That is what? 14 minus 6. 14 minus 6 will give us what? 8. You understand? So the value for error is 8. I mean the error degree of freedom will be what? 8. Do you understand? Okay, without wasting our time, let's calculate the, okay, yeah, let's fill the sum of square. The total sum of square that we calculate is what? 14.07. So here I'm going to have 14.07. And for the next block, for the block sum of square is what? 0.042. 0.042. Then variety sum of square is what? 13.67. So I'm going to have 13.67. Then error sum of square, which is what? 0.358. 0.358. Do you understand? Okay, now mean square. Mean square is given by this formula. Okay, I'm going to erase this now. Okay, since we are done with variety sum of squared, I'm going to erase this so that we can use that space for mean square. Okay, mean square is given by this formula. Mean squared is equals to, please pay attention, sum of squared all over degree of freedom. Now, we want to determine the total mean squared. The total mean squared will be equals to the total sum of squared all over the total degree of freedom. Do you understand? The total sum of squared is what? 14.07. 14.07. The total degree of freedom was 14. Total sum of squared is 14.07. Total degree of freedom is 14. So here, 14.07 divided by 14, that is 1.005. Okay, 1.005. You can check with your calculator. So here I'm going to have 1.005. Okay, now let's calculate the block mean squared. The block mean squared is equals to the block sum of squared all over the block degree of freedom. You understand? The block sum of squared is what? 0.042. 0.042 all over the block degree of freedom is what? 2. So I'm going to have divided by 2. Now 0.042 divided by 2, that is 0.021. You understand? Here I'm going to have 0.021. Okay, so the value will be 0.021. Okay, now let's calculate the variety mean squared. The variety mean squared is equals to variety sum of squared all over the variety degree of freedom. You understand? The variety sum of squared is what? 13.67. So that will be 13.67 all over the variety degree of freedom is what? 4. So this will be all over 4. 13.67 divided by 4, that is 3.4175. 3.4175. You understand? So 3.4175. You understand? Okay. Now let's calculate the error degree of freedom. The degree of freedom for error will be error sum of squared divided by error degree of freedom. You understand? So error mean squared. The mean square of error, the mean square of error is error sum of squared all over the error degree of freedom. You understand? Error sum of squared is 0.358 all over 8. So 0.358 all over 8 is 0.0448. You understand? So here I'm going to have 0.0448. 0.0448. 0.0448. So that is the mean square of error. So now, don't forget, we are given that the F tabulated at 5% for block is what? 4.46. So we have been given this 4.46 for block, and for variety it is 3.84. You understand? So this will be 3.84. Now we don't need the F calculated for total or this and this. We don't need this. We only need the F calculated, the calculated critical value for block and variety. You understand? So that's what I'm going to do now. Let's determine the calculated critical value, that is F cal. Now, how do we determine the F calculated for block? Let's start with the block. So please, are you done with this? I want to erase it. Now, the F calculated, okay, let me give you the formula. F calculated is equals to mean squared all over error mean squared. I'm going to explain, okay? F calculated is equals to mean squared all over error mean squared. It simply means that the mean square of the parameters that we want to calculate the F calculated divided by error mean squared, that will give us the F calculated of that parameters. Now we want to determine the mean square of the F calculated of block. So the block F calculated for block F cal will be equals to block mean squared all over error mean squared. You understand? Now, block mean squared is what? The block mean squared is 0.021. 0.021 all over error mean squared, which is 0.0448. 0448. Okay? Now, block mean squared is 0.021 all over 0.0448. If you punch that in your calculator, you're going to have 0.4688. 0.46. So that is the mean square for block. So here I'm going to have 0.4688. You understand? Okay. Now let's determine the variety F cap. The F calculated for variety is equals to variety mean squared all over error mean squared. Do you understand? Variety mean squared is what? Variety mean squared is 3.4175 all over 0.0448, which is the error mean squared. So if you punch your calculator, 3.4175 divided by 0.0448, that is 76.28. So here I'm going to have 76.28. 76.28. So we have already computed the Anova table. This is the Anova table that we are asked to compute. Just you understand to this point. Now we are told to draw our inference. Pay attention. I want to interpret this now. We are told to draw our inference. The F tabulated at 5% is 3.84 and F calculated is 76.28. Since the F calculated is greater than the F tabulated at 5%, 5% level of significance, we conclude that the experiment shows significant difference among the 5 treatments of variety. That is my inference. You understand? That is the inference or the conclusion. You understand? Because you might be told there are some questions. I've seen some questions on another table that they will ask you to what do you conclude or draw your inference. I just explained what it means now. Now, if you look at this, the F tabulated at 5% level of significance is what? 3.84. Now, the calculated critical value that we do is what? 76.28. You can see that this 76.28 is greater than 5%. You understand? So, I conclude that the since the F tabulated is greater than the F tabulated at 5% level of significance, I conclude that the experiment shows significant difference among the five treatments of variety. So, that is the conclusion. Please, I want to know what you learned in this video. Let me know in the comment section. What do you learn? Is there anything that you would like me to, explain on, or if you have any question regarding this, let me know in the comment section. And at the same time, don't forget to like this video. If this video has been helpful to you, don't forget to like and share it to people that need it like you. You understand? So that YouTube will push it to many viewers that need it. You understand? Thank you for watching. Stay blessed.